Hello everyone and welcome to ipshuttle.com. My name is Vakas and I will be your instructor for this free CCNA course. Today we will be covering what are the broadcast domains and collision domains, what are the different types of VLANs and why you need it, and how to configure it. Let's get started. Before we can understand the concept of VLAN, it is important to understand what are the broadcast domains and what is collision domains. If you send a single packet and it is sent out to every port or group of ports, regardless you have requested the traffic or no, so that will be becoming the part of broadcast domains. Collision domains is when it is a shared medium and you are sharing the resources for sending or receiving the data and two different devices tries to send at the same time. That is when the collision happens. Let's try to understand it with a simple example. So we have two different zones, zone A and zone B. If you notice that both of them are in different subnet IDs, but it's a hub network, so it's a shared network. When one network tries to broadcast, you will notice that the broadcast packets are reaching to the other zone as well, regardless it has requested or no. This is a typical example of shared medium. In the hub scenario, everything is part of single broadcast domain and one collision domain. So everything will be broadcasted regardless what is the zone or networks or collision domains are. Let's take an example of a switch. When it is considered a switch in the network, everything is part of single broadcast domain. Interesting. But everything is a separate collision domain. Whenever there is a concept of hub versus switches, so you need to be understanding the critical difference between both. Hub is part of single broadcast domain, single collision domain. And when it comes to a switch, it is part of one broadcast domain by default and every port is a collision domain. So there is no chances of getting collided. I have a question for you. Let's say we have a hub. In the hub network, you will notice that there are 12 ports. So you have to answer how many collision domains will be there and how many broadcast domains will be there. Second question, let's assume it has 24 ports. How many broadcast domains are there by default and how many collision domains are there? Put your answer in the comment. Let's try to understand the basics of VLANs, why we need it. What is the challenge we are trying to solve? So let's take an example of simple communication network. You have accounts and you have HR. What is the challenge here? They might be on different floors. They might be sitting on different level of the building, or they are apart more than 100 meters. Since the copper cables cannot be exceeding 100 meters, what is the other solution? You cannot give switches to every different department to keep their broadcast domain separate, because you have different networks. You don't want one traffic to get mixed up with the other one. So what is the other solution? That is where VLANs comes up. VLANs virtually converts a switch into logical broadcast domains so that one traffic does not mix up with the other one. It's time to understand what are the various types of VLANs. There are three basic types. Access VLAN is also sometimes referred as data VLAN, and the second one is voice VLAN, and the third one is default VLANs. We will try to understand one by one what each VLAN does. So the access VLANs are the VLANs where single port is connected and there is only a single host who is going to send the traffic. That is when we call it access port or access VLAN. The next one we have is the voice VLANs. Voice VLAN is, since the name describes itself, that means there is something related with the voice. We have IP phone, there is different kind of video conferencing solutions are there which needs a voice VLAN. Last one we have is the default VLANs. It is sometimes referred as untagged VLANs or native VLANs in various cases. So don't worry on that. We will be discussing in the future. For now, just understand this part that it's just different names for the same thing. Giving a brief of the lab, we have zone A, which is 192.168.1.0. We have zone B, which is 172.16.1.0/24. I have named the PCs. Here is our John and I have Chris. We have Hannah and Andy. And let's say we are pinging from the John to broadcast address. What will be the broadcast address? It will be 192.168.1.255. If we try to ping this IP address, you will notice what is going to happen. The traffic will be coming from this port specific to the switch and it will be exiting to all the different zones regardless it is intended for it, because it is not currently in the VLAN. And once we have configured the VLAN, let's say zone A, we will be assigning the VLAN 100 and zone B we will be assigning VLAN 200. Okay, you will notice that if we will try to broadcast the same address, the traffic is only limited to this zone and it's not moving to zone B. That is exactly what we want to do in the real life as well. We don't want the traffic to be mixed up from different subnets and different zones. These PCs are already configured, so we don't need to configure the basic IP addresses and all those things. Let's move right into the switch. So I have issued the command show VLAN. You will notice we have default VLAN, which we have discussed that it's an untagged VLAN. All of the ports currently are in the same zone, okay, including these ports. So we will be trying to segregate these using the VLANs. Giga Ethernet 1/0/1, which is part of zone A, and we have Giga Ethernet 1/0/3, which is part of zone A. Let's try to configure it as an access ports. We will be making it a data VLAN mainly, so that only one host can connect from here. Alright, the first thing we will be doing in the lab is we will be configuring the different VLANs. Let's say we have VLAN 100. Let's name it zone A. The naming is optional, but it's good practice. So let's create another VLAN and name it zone B. Alright, so we have two VLANs. Let's say what happened. Show VLAN, and you will notice here there are two different VLANs, but there are no ports. Alright, so let's head back to the lab. We will be assigning interface Giga Ethernet 1/0/1 switch port mode access. Alright, and switch port access VLAN 100. So we have assigned it to be part of VLAN 100. Let's see show VLAN, and you will notice we have one port. Now we need to assign Giga Ethernet 1/0/3 under this one. Let's go back. So let's go back and make it Giga Ethernet 1/0/3 switch port mode access switch port access VLAN 100. So show VLAN, you will notice we have few VLANs in zone A, but we don't have anything in zone B. Let's go and configure it. In zone B, we have interface 5 and interface 4. Let's configure it under zone B. The same thing, let's configure terminal, interface Giga Ethernet 1/0/4, switch port mode access, switch port access VLAN 200. And interface Giga Ethernet 1/0/5, switch port mode access, switch port access VLAN 200. Let's see, show VLAN, and we have the VLAN. And we have both of the zones configured. Now let's try what happens when we will try to broadcast. The same thing what we have did it. We seen it that it was broadcasting to all the networks. Now we will notice that what happens. Let's try to ping it from the PC John. We will try to ping the broadcast address, which is 192.168.1.255. And you see we got a response from 1.2. The last part we will be having is the voice VLANs, how to configure it. The voice VLAN, I have connected the IP phone here, and the port is 1/0/6. Let's configure the switch to give it a voice VLAN. And let's assume we have VLAN 300. We will name it voice. Alright, let's go back to interface Giga Ethernet 1/0/6 and switch port access, switch port voice VLAN 300. Let's go back to the IP phone and let's try to see if the VLAN has been assigned. If you try to do it this way, you will notice there is a VLAN, and which is VLAN 300, and it is up. So we have successfully assigned it a voice VLAN. Alright, so that's how we configure the voice VLANs. Can you do the data and voice both on the same VLAN? Yes, absolutely we can do that. Just a quick example, we can configure the same interface 1/0/6 switch port access VLAN. Let's try to put it in the zone A, VLAN 100. Alright, if you notice that show VLAN, you will see zone A and B have few ports, and Giga Ethernet 1/0/6, which was actually a voice VLAN, it is part of two different VLANs. Did you notice that part? All right, let's go back and configure one PC here. Let's keep it here in the zone A itself because we have already assigned the VLAN. Let's connect it and with the PC. So let's give it an IP address 192.168.1.10. All right, I assigned it a subnet mask. Ping John. Ping 192.168.1.1, and we have the reply. So we have successfully configured voice VLAN and data VLAN on the same port. We have the PC working. If I have improved your knowledge in any ways, please hit like and subscribe so you can be notified for upcoming lectures. We will be definitely covering CCNA, NP, and IE. I want you to be expert of networking. And don't forget to let me know in the comment section what will be the next topic. I will be waiting for it. Thank you so much and have a nice day. Take care.